So in this lesson, we are going to see the derivative quotient rule for derivative. We have learned the power rule. So when the f of x equals a times x to the exponent n, then the derivative of this equals two steps. N bring to the front, then n minus 1. So this is a power rule, and also we have learned is if we have a function that is a two functions multiplication, then the product rule is h prime at x equals f prime at x, g at x, then plus f at x, g prime of x. So this is a two rules we have learned, product rule and power rule, and today we are going to learn the quotient rule. Quotient means divide. So what if we have two functions, not multiplication but division? And here is a quotient rule, and we are going to prove why it is this way. So if a function h at x equals f at x divided by g at x, then the derivative of h at x equals g at x squared. For the denominator, the numerator is first function, first come, first derivative. So f prime of x times g at x minus f at x, g prime of x. So we have two primes, first come, first derivative, then minus the second one derivative, all over g squared x. And in the xy notation, it will be dy over dx equals denominator squared, then first come, first derivative. So u prime v minus uv prime. And we are going to prove it. And how are we going to prove it? We are going to use the product rule. That is what we know already. So we want to change the h at x equals f at x over g at x to function multiplication. Get rid of the denominator by times it to other side. So we move g at x to other side, do the opposite operation is times g at x to both sides. Then g at x cancel out. The right side only you have h f at x. On the left side we have g at x multiply h at x. And we know how to do the derivative for this function very well. So we are going to take derivatives to both sides. So multiplication derivative, we have g prime first function derivative times second function, then plus first function times the second function derivative equals the other side f at x derivative is f prime of x. Then what we want to find is we want to find h prime of x. So we want to move the g prime h at x to other side. We want to solve for h prime x. So g at x h prime of x equals f prime of x minus g prime x h at x. Then we want to move the g at x to other side. So we want to divide it g at x to both sides. Then we have h prime of x equals f prime at x of x minus g prime of x. Then h at x. We don't want to have the h at x in our formula because here we only have f at x, g at x. So we want to change substitute the h at x to here. So h at x, we change it to f at x over g at x. Then it is close to our final, so we want to just simplify it. H prime of x equals, we keep the g at x at denominator and f prime of x minus this multiplication with fraction, we are going to use divide by 1. So g prime of x divided by 1 times this one, numerator times numerator, denominator times denominator. 1 times g at x is g at x. Then this is a fraction, adding, subtracting, we divide by 1. So we want to change them to common denominator. This is g at x, we want to change this 1 to g at x by times g at x to both top and bottom. Then continue, we are going to have h prime of x equals the numerator g at x, we have the common denominator, then we still have g at x at the bottom. So the numerator, we have common denominator g at x, then the numerator subtract f prime x g at x minus g prime x f at x divide by g at x, then also divide by g at x at bottom. So this is division. We want to change this division to multiplication. So we continue f prime x g x minus g prime x f at x all over g at x. Divide by g at x, we want to change it to multiplication. So this is a g at x over 1. Division, change it to multiplication, we flip it. Will becomes 1 over g at x. Then numerator times numerator, denominator times denominator, you will see is f prime x g at x minus g prime of x f at x times 1. It doesn't change, then g at x times g at x is g squared at x. And check the formula here. The quotient rule is same as our proof. So I just change the g prime x at front. You could just, these two multiplication, you can switch them around. So you could write f at x times g prime x. So it's same. So I may just rewrite it, f at x first, but they are same. So just f at x, g prime x is similar with our product rule. F prime g product rule is plus, f g prime here is minus. Okay, so this is a proof of the quotient rule. And denominator squared, first come first derivative. Okay, and after that we are going to use this quotient rule to find the derivative of a function, and the derivative of a function is the slope of the tangent at that point. And you may wonder why we want to find the slope of the tangent at certain point for a function. The reason for that is the slope at this maximum minimum point, the slope is 0. And the maximum minimum point is what we are interested in. So we want to find this point. How to find the point? We want to use a derivative, then let the derivative equal 0. We can find the x value, then we know where we can have the maximum value or minimum value. So this is where we are going to use the derivative values of a function. So now this is one example. Determine this derivative of function f at x. It is f prime x. This is a quotient. So this is one function, this is another function, and this function two terms, this function two terms. So we are going to see f prime of x equals denominator squared, x cubed minus 1 squared. The first function, first derivative. So this one will be 2x minus 3 derivative. Each term we do the derivative. So 2x is 2 times exponent 1 to the front, then exponent 1 minus 1 is 0. This is constant, x to the exponent 0. You do the derivative, bring the 0 to the front, will be 0. So the first function derivative is 2 times 1 times x to the exponent 0. Then don't forget, you need to bring the denominator up. X cubed minus 1. Then minus first function, we don't change it. Then we are going to do the derivative to the second function. X cubed minus 1. So two terms. Each term is a polynomial. So this one, 3 exponent bring to the front, then exponent minus 1. 3 minus 1 is 2. The constant x to the exponent 0, 0 to the front will be 0, so it's just minus 0. Then we just simplify it a little bit. So 2 times 1 times x to the exponent 0 is 1, so it's 2. X cubed minus 1 minus 2x minus 3, then 3x squared minus 0 is 3x squared, all over x cubed minus 1 bracket squared. So it didn't say simplify it, we could just leave it in this way, but I do want to get rid of the x to exponent 0 minus 0 out, so I want you to write it in this way, and the mark will be given. You have the first function derivative correctly, second function derivative correctly, then you have the x squared, the denominator squared, the minus correct. You have 3 marks. So this is how this short answer will be marked. And after that, we are going to see one more example. Another example, find the equation of the tangent. So whenever you see find the equation of a tangent, you know that you are dealing with a straight line. And for a straight line, the slope y-intercept form is mx plus b. And in this equation of a line, you have to find the slope and the b. And the easy way you can remember to, in order to find the equation of a line, you can see the steps is MBA. So you need to find the slope first, then the y-intercept, then statement. Okay, so this is a steps, statement, and this is your y-intercept. This is your slope. We always follow finding the slope first, then finding y-intercept, then statement. When we are looking for the y-intercept, there are 4 letters. In order to find the b, we have to have m, xy given. Xy is a point on the line. Okay, so f of x equals 2x plus 3 over x squared plus 1 at x equals 0. So from this x equals 0, we are able to find the slope, the point at the tangent. So x equals 0, we sub in, we find the f at 0, this is the y value. Okay, So we are going to focus on finding the slope first. And the slope is the derivative of function f of x, f prime of x. So this is a quotient. So quotient means division. We are going to use a formula for this. So denominator squared first. Then first come first the derivative. So 2x plus 3 derivative give us 2. Then times the denominator. Then minus first function stay. The second function derivative x squared, bring the 2 to the front, and degree minus 1 is 1, so 2x, constant is 0. Then this is a derivative f prime of x. Then we want to find the slope at x equals 0. We sub in x equals 0 to this derivative, so m equals f prime of 0. We sub in x equals 0 to the expression. So 2 times 0, then plus 3, then 2 times 0, all over 0 squared plus 1 bracket squared. Then 0 squared plus 1 is 1, so we have 2 times 1. And all this one, 2 times 0 give you 0, it's just whole thing is 0. 0 squared is 0 plus 1 is 1. 1 squared is 1. So 2 times 1 minus 0 is 2, minus 0 is 2. So 2 divided by 1 is 2. So please, if you have 2 over 1, simplify it to integer. Don't keep the 1 at the denominator. We don't want to see fractions if it's possible. So this is a slope. And we want to sub in mxy, so x equals 0. We want to find the y value. Y value equals, when x equals 0 as an input, the output of function f, we call this function notation. This output of the f at 0 is your y value. So we sub in. Remember, this is original function. So x equals 0, replace x with 0. So 0 squared plus 1. So 2 times 0 is 0, so equals 0 plus 3 is 3. Denominator is 1, so we have 3. So now we have m equals 2, xy equals 0, 3. We have 3 given. We substitute this one to this equation. 4 unknown. We have 3 given. We only have 1 unknown. We can find it. So 4 variables, 3 must be given in order to find the one left. Okay. So into y equals mx plus b. So y equals 3. m equals 2, x equals 0, then plus b. So 2 times 0 is 0, so b equals 3. Or if you could see 0, 3 is the y-intercept, you could just write a statement right away. So y equals sub m equals 2, b equals 3 into y equals mx plus b. xy need to stay. We have both x, y there, then we could have one x value, you find one y value, you have infinite number of points, then you can form the line. Okay. We have yx, then you solve, sub in, then you can solve for y. So xy stay, and b sub in, then you have the equation of a line. So this is y equals 2x plus b. So y-intercept is 3 and rise over 1 is 2 over 1. Okay, so this is an equation of the tangent for this question. Then we are going to practice one more. So determine the coordinates of each point on the graph, just like what I said. We want to see where the tangent, the slope is 0, because when the tangent, the slope is 0, then you could have maximum, minimum. You may have maximum or minimum point, and those are the points that we are interested in. So maximum may be the maximum revenue, and the lowest is the lowest cost. So they are the value that we are interested in. Okay, so it asks you where the tangent is horizontal. If tangent is horizontal, then slope is 0. So we are looking for m equals 0. And the m slope of tangent is a derivative of a function. So we are going to see the derivative of f at x equals. So you could pause the video and do it by yourself, then later you can check your answers. So this one, you have one function, this is another function. So two functions divide. Denominator squared, so square root x squared. Then the first come first, the derivative, 2x plus 8, 2x, x exponent 1, so bring the 1 to the front. So 2 times 1 times x to the exponent, 1 minus 1 is 0, so it will be just 2. Then constant, the derivative is 0. Copy the denominator here, then minus. Copy the numerator here, then do the derivative to the denominator. So denominator square root x, we want to change it to the x to the exponent square root. No index number means 2, so this is 1. So 1 power over the index, the roots, 1 or 2. Then we are going to do the derivative, bring the numerator exponent to the front, is 1 over 2. Then the exponent minus 1. So this is our prime. We simplify it a little bit. Square root x squared is cancel each other. They are inverse functions, so squared, square root, they are inverse functions, they cancel each other. Then 2 square root x minus 2x plus 8 times 1 over 2. This one, 1 over 2 minus 1 is x to the exponent, negative 1 over 2. Then they want us to find the slope is 0, so means f prime at x, the slope of tangent equals 0, so we sub in this one equals 0. So how to solve this equation? We want to get rid of the x, we times x denominator to other side. So 0 times x give you 0 equals 2 square root x minus, so this one we treat it as denominator is 1, so 1 times 2 is 2, 2x plus 8. Then this is a x to the exponent negative 1 over 2. We could write it as square root x at the denominator. We flip it. Then we don't want to see this denominator again. We want a common denominator here. So we are going to times 2 square root x to both top and bottom to get the common denominator. So we have 0 equals 2 square root x. Then 2 times square root x times 2 square root x. The number at front times 2 times 2 give us 4. Square root x times square root x give us x. Then minus 2x plus 8. So we want to get rid of the denominator, times 8 to the other side. We have 0 equals 4x minus, get rid of the bracket. The reason is we want to collect the like terms, so we don't want to see the brackets. So minus 2x minus 8, and this is a linear equation because degree for the variable x, highest degree is 1. So 4x minus 2x, collect the like terms, we have 2x. We don't want to see the numbers at the same side with x. We move the negative 8 to other side by doing opposite operation, plus 8 to both sides. 8 minus 8 is 0, is gone. 0 plus 8 is 8. Then, in order to solve for x, we don't want to see the 2. The opposite operation to bring the 2 to other side, 2 times x, opposite is divide. We divided 2 to both sides. So then 8 divided by 2 give you 4. 2x divided by 2 give you x. So we have x equals 4. And this is the x coordinate of the point on the graph. Okay, this is 4 on the graph, maybe somewhere here. So we want to find the point, we want to find the y value. And remember here, you want to sub it back to the original function. Y equals f at 4, not f prime at 4. So f at 4, we sub it back. We are going to have 2 times 4 plus 8 divided by square root 4. So square root 4 give us a perfect square number. 2 squared equals 4. So square root of 2 squared give us 2. 2 times 4, 8 plus 8. Then continue, 16 divided by 2 give us 8. Then we have the conclusion, the statement. So don't forget, write the statement. So therefore, the 3 dots, 1 on top, 2 at bottom, is a short form for therefore. So therefore, at point 4, x first, y second, at 4, 8, the slope of the tangent is 0. And in future, you will see this is most of the time we are looking for this point where the slope of tangent is 0, because this is either maybe maximum or maybe minimum points. Okay, and check your understanding of sign work is delta minus 2.4. So today's lesson, what we have covered is just derive the quotient rule. After we have the quotient rule, we use the quotient rule to find the derivative of the function, that is two functions divided each other. Okay, thanks for watching.